Number one, I do want to simplify the expression. I'm not solving. It's not going to be x equals any. So in order to simplify this, I'm going to look at this first trinomial in the numerator position. I'm asking myself what two numbers multiply to equal negative 12 and combine to equal positive 11. And I like a positive 12 and a negative 1. They multiply and they combine. Now what I need to make sure to do is not forget about bottoms up. So when I simplify, the numerator is x plus 2, push up, and it's going to be 6x minus 1. This is the numerator position. In the denominator, it breaks into x plus 2 and x minus 2. Remember, when you are dividing, it's the second fraction that you're going to take the reciprocal. So division turns into multiplying. This will go on top. On the bottom will be 36x squared minus 1. Now 36x squared minus 1 is a difference of squares. 6x plus 1 and 6x minus 1. On top, x, 2, 2, 2. So there's 2 things here and 3 things. Alright, I'm going to bring down the very first. In this position, I take the plus or minus in between the two terms. X is in front, 2 is in back. I have 2 x's left, they go in front. I have 2 2's left, they go in back. Remember, this is always positive. And what goes in the middle? Well, because this was subtraction, this will be addition. And how do I determine this term? I just multiply these two. 2x. So I've set it up by factoring, and now I need to simplify. If there's any one group of x plus 2 in the bottom, I get to cancel it out. Remember, they don't actually cancel, they simplify to 1. Here's a 6x minus y and a 6x minus 1, x minus 2, and here, right, x squared plus 2x plus 4 over 6x plus 1. Okay, in number 2, again, I'm simplifying, I'm not solving, so it won't be x equals a numeric value. We're just going to rewrite this. So first I need to factor this into x plus 3 and x minus 3. And I recognize that the LCM, because when I'm adding or subtracting fractions, I do need a common denominator, will be x plus 3 and x minus 3. So I'm good here. This contains an x plus 3 and x minus 3, but the right-hand denominator is missing an x minus 3. Whatever you attach to the bottom, you must also attach to the top. Alright, so I'm ready to keep going. This is what I have. So on top I have 2x minus 7 times the quantity, x subtract 3. And on the bottom I have the common denominator of x plus 3 and x minus 3, which could also be written as x squared minus 9. Let's distribute. 2x minus 7x plus 21. And when I combine like terms, I end up with a negative 5x plus 21 all over x plus 3 and x minus 3. Alright, in number 3, I'm going to be factoring by grouping. So when I look at the first 2 terms, I'm going to factor out an x squared, and I'd be left with 2x minus 3. And now I'm going to rewrite this 2x minus 3 and put a question mark in front. Is there a number I can take times 2x and I end up with a negative 10x? Yeah, that'd be negative 5. And now is negative 5 times negative 3 15? It is. And because of that, I can keep going. So in front of the first, I have an x squared minus 5 is in front of the second, and they both have a 2x minus 3. This is the numerator. I've just rewritten it. That's what simplifying is here. I've just rewritten it. Now on the bottom, I go 2 times negative 9 is negative 18. Do I know 2 numbers that multiply to equal negative 18, but combine to equal positive 3? I think that's going to be 6 and negative 3. Multiply and combine. Okay, so I think it's 6 and negative 3. How does that work? Well, plus 6 and minus 3. And don't forget, because the leading coefficient is a 2, I do need to put it on the bottom. 6 divided by 2 is 3, so x plus 3. 3 over 2 cannot be reduced. 3 over 2 can be reduced. The bottom number pushes up. You get 2x minus 3. So I've done everything right, but to simplify means to fully simplify. I have a group here and a group here, and I'm able to reduce those. Final answer is x squared minus 5 over x plus. All right, number 4. So What's different about 1, 2, and 3 is we started with the word simplify, but now we have the verb solve. That means I'm going to have an answer like x equals something. And notice that, remember, we can never have a denominator that equals 0. So the only number I would plug in and be in trouble with is if x is 0, I'm in trouble. So I know x cannot equal 0. I know if I can't have a final answer of 0, otherwise I'd have 0 on the bottom in the denominator position. Okay. So, how do I solve this? In order to solve this, I'm going to start by finding a common denominator, or identifying the LCM. So the LCM here. So remember, x squared is the same as x and x. So this has 2x, this has 1, and this has none. So I want everyone to have 2 x's. Okay, it has 2 x's, I don't need to touch it. I need to attach an x to the bottom and top, and here I need to attach 2 x's. So now, because the denominators are all the same and I'm working with an equation, I get to wipe out the bottom, and I have 1x squared minus 1x equals 12. I'm going to move the 12 over to the same side as the other two terms, and now I'm going to see, is this factorable? If I can factor and solve it, I'm good. If not, I'll use the quadratic equation. Maybe I'll use graphing. I do an exact answer or completing the square as a method to solve. Are there two things that multiply to equal negative 12 and combine to equal negative 4? Yeah. Or negative 1. Yeah. It'd be negative 4 and 3. Combine and multiply. All right. So x minus 4 and x plus 3. Now when you solve, you get an answer of x equals 4 and x equals negative 3. Remember, it can't be 0. Neither one is 0, so I do have two answers. So 5 is just a little more complicated than 4. Again, we start with the verb solve. So in this box, I want to have an answer of x equals some number. But first, let's figure out what x cannot be. So I'm going to look in the denominator. And if the denominator contains an x, I'm going to set it equal to 0. So set this equal to 0. I know x cannot equal 0. Okay, this contains a variable. So I take x plus 1, set it equal to 0, and solve. I know x cannot equal negative 1. Because this does not have a variable, I don't worry about it. So when I get done with this problem and I get an answer or answers for x, I just need to make sure that the answers are not 0 or negative 1, or we consider those to be extraneous solutions. So how do we get started? We're going to start by identifying the LCM. So I need to have a single x by itself, and I need to have an x plus 1. And sure, I could say a 1, but attaching a 1 to something does not change anything. A common mistake I've seen students make in grading exams is students understand they need to find a common denominator, and they're like, okay, I think it should be x plus 1. So they just go plus 1, plus 1. You can't just add. You have to attach something by multiplying. So this is a single x. They all need to have a single x. They all need to have a group of x plus 1. And sure, they can have a 1, but again, that's not going to change anything, so we're not going to worry about that. So what is this first term missing? It's missing an x plus 1. So it's missing an x plus 1. I'm going to attach it to the top and to the bottom. This is missing a single x. Attach it to the top and attach it to the bottom. This is missing both. Missing a single x and missing an x plus 1. Now, when you have an equation and you're solving and you found a common denominator, which we have, we get to wipe out the denominators and only worry about solving the top. So 2x, be careful, a lot of students in the past put plus 1, remember it's plus 2, distribute through. This is 4x squared. Now this is tricky. So first you're going to go, remember this is 4x and then take it times. So I have 4x times x, x squared, and I have 4x times 1. What do I do with this? Cancel and cancel, and I have 2x plus 2 equals negative 4x. I'm going to move the x's to one side. It doesn't matter what side. And then I'm going to isolate the x by dividing. And so be careful, x does not equal negative 3 here. It does not equal negative 3. It equals negative 1/3, or negative 2/6. Now how do I know that works? Well, it's not one of the numbers that we declared. It couldn't be. And so the final answer is negative number 6. So number 6, there's 2 different ways to do this, and I do want to show you both ways, but it really depends on what you find to be the easiest to do. Now maybe you decide, okay, I like doing cross multiplication, so you're going to go with something like this. So you're going to take x times x minus 3 and set it equal to 5 times 3x minus 9. That wouldn't be my method, but some students feel most comfortable with this. X squared minus 3x equals 15x plus 45. And then they move everything to one side. It's always optimal to move to the side that has the x squared. So minus 3x, move it over, minus 15x, move over minus 45. So x squared minus 18x minus 45. And now we got to see, is this factorable? If it's not, we'll have to use a different method to solve. So what multiplies to equal negative 45 and combines to equal negative 18? That would be, let's see, cannot be 15 and 3. This should have been a negative 45. So this was a negative 45. When it moves over, it's positive. All right, so negative 15 and negative 3 combines to give you a negative 18, and then it multiplies to give you the positive 45. I messed up on my sign there. Okay, so I like a negative 15 and a negative 3, and because of leading coefficients 1, I don't have to worry about bottoms up. So I'm declaring one answer is 15 and the other answer is 3. But what I forgot to do before I started is I forgot to go, I have to decide what can it not be. So I take 3x minus 9. Because it has a variable in the bottom, I set it equal to 0 and I solve. Okay, it cannot be 3. And then I take the other one. I set it equal to 0 and I solve. Okay, it can't be 3. So when I finish, I know it cannot be an answer of 3. So yes, I have 2 answers, but remember it can't be 3. I believe the answer is 15. Is there another way to do that? I prefer a different way because when I look at this problem, I personally see that I can factor out a 3. And then when I'm looking here, I'm like, okay, is there a simpler way to do this? Yeah, if I find a common denominator, then I'm able to wipe out the bottom. So when I look at these, I'm saying, oh, this only needs to have a 3 attached, and they're exactly the same. So I attach a 3 to the top and bottom, wipe out the bottom, x equals 15. How do I do number 7? So I could graph it, and that works as well. It absolutely works. Unfortunately, within this system, you would not be able to see it if I put it into decimals. Can you grab me a graphing calculator, please, Emiliano? Thank you very much. So, notice that if there is a negative here, it's tricky. If there's a negative here, cross it out and always put it up top if there's a negative, okay? So, how do I determine the vertical asymptote? Remember, vertical asymptote and horizontal asymptote. Horizontal is always going to be y equals some numerical value. Vertical is always going to be x equals some numerical value. So the vertical asymptotes come from the bottom. So if I take this and factor it, it's x plus 5 and x minus 5. So if I would take each one of those and set it equal to 0 and solve, I'd get answers of negative 5, and then the other time I would get an answer of positive 5. Those are our vertical asymptotes. X equals 5 and x equals negative 5. Now, how do we find the x-intercepts? We take the top, we set it equal to 0, and we solve. And we can also see that when we look at a graph. So I'm going to divide by negative 4, divide by negative 4, x squared. 0 divided by anything is 0, and the square root of 0 is just simply 0. There's not a plus or minus 0. Now, in this position, when the degree on top is equal to the degree on the bottom, we're going to divide the leading coefficients. So, negative 4 divided by 1 is negative 4. Now, domain and range, you may find ease on actually graphing it. I think it's easier to see in decimals than it is to see in a graphing calculator. You're welcome to use that for the test, but I'm going to put parentheses around the bottom here. So there is the numerator divided by, and here would be the denominator. Okay, I want to make sure the window's fine. And now what you can't see is you can't see the asymptotes. And I'm unable to make them dotted, I believe, in this system. But I do want to show you how, remember we have asymptotes at 5 vertically and at negative 4. So I do want to just show you what those would look like. Let's see if I can do it. X equals, I can't do that nicely. But if I could draw here, this is the dotted line of x equals 5, x equals negative 5, and y equals negative 4. So domain, it comes in from the far left, and it keeps coming. As it approaches the line, as it approaches the vertical asymptote of negative 5, it does not touch it, it approaches it. It jumps over it, and it goes from negative 5 to positive 5. And it jumps over x equals 5 as an asymptote, and it goes from 5 as it goes on to the right. What about the range? We start at the bottom. Comes up from the bottom, comes up from the bottom, and it keeps coming up until it approaches the horizontal asymptote of negative 4. It does not touch it. And then there's all this dead space. And when it starts again, it starts at a y value of 0. We have to include that, and there's no limit how high it goes. Now, as it moves out to the far left and out to the far right, in both cases, it approaches the horizontal asymptote of negative 4. This will be much easier to see in decimal. How do I write the square root of x? Well, there's two ways. This is called the radical exponent way, and this is called the rational exponent way. I'd be okay if you put in 2 here as well. You wouldn't have to. Radical and rational exponent way. These are 2 different ways. How do we simplify number 9? Well, remember, because we're multiplying, we have the same base, it makes it pretty easy. I'm going to write these in the same form. So this nth root is 6, this 1/6, 4/5, and negative 1/3. And then I know I'm going to divide it by x to the positive 1/4. So how do we do it on a calculator? So using our parentheses, we'll have 1/6 plus 4/5 plus, remember the negative signs below the 3. I don't want to round. I'm going to turn it back into a fraction by hitting map, fraction, enter, enter. So on top, I have 19 over 30. And what do I do now? Since I want to simplify, it's not solving, it's not x equals. When you have the same base and you're dividing, you subtract. In parentheses, I have 19 over 30, subtract 1/4, and simplify it to get 23 over 6. How do I simplify number 10? Well, notice that we have the same nth root. That's helpful. Same nth root. And so I'm going to take and rewrite this. 5 times 4 is 20. 2 times 4 is 8. I have a total of 9 A's and a total of 27 B's. Okay, so when I look at that chart, when I look at this chart, and this chart will be available to you to use, I want to go to the third column and locate 8. So the third root of 8 is 2. So when a 2 pops out here, it's not just 20. Remember, it's 20 times 2. And some of you can just do that right away and turn it into a 40. Now, let's evaluate the rest of this. How many groups of 3 can you take from 9? Well, that's like saying 9 times 3, or 9 divided by 3. 9 divided by 3 is 3. How many groups of 3 are located in 27? Well, 27 divided by 3 is 9. 40, A to the third, B to the... How do I do this problem? Okay, I want to locate column number 2, and I see no 8. So then I ask myself, can I take 8, the denominator, can I take 8 times something to get one of these numbers? Oh yeah, 8 times 2 is 16. I'm focused on that denominator, and whatever you do to the denominator, you must also do to the numerator. 2 over 16. Okay, let's rewrite it. And now I can evaluate the bottom, because in this column there's a 16, and the square root of 16 is 4. So down here, this is our simplified answer. Remember, I cannot simplify this to like a 1/2. They are not within like terms. 12 is nice, regardless what the nth root is. As long as there's something not in front or in back. There's not something extra in here in front or in back. When you have the same nth root, we're able just to wipe out the radicals, and we have 4x minus 9 equals 3x minus 2. Okay, moving 3 over. By subtracting, I have 4x minus 3x. There's still a 9 there. And then move the 9 over. So opposite of subtracting the 9 would be adding the 9. At this point, I have 1x equals 7. Divided by 1. Divided by 1 is 7. That's what I believe. Let's check. So I'm going to take 28 here. 28 minus 9. I get an answer of 19. So this is the square root of 19 when I plug this in. Square root of 19. Then I plug in 7 here. I have 3 times 7. Subtract 2 is 19 again. I just proved the two sides are equal. This is a Alright, so I want to solve again. I'm going to have an answer. Not a simplified answer, it will be but just a final answer of x equals something. And I expect to get rid of this radical. So I look at and see what this is. This is a 2. To remove the radical, I take whatever the nth root is and I do it to both sides. 4x plus 12 equals, remember this is the same as now as x squared. I think it's always easiest to move everything to the side of the x squared. So I move the 4 and the 12 over. Now if this is not factorable, I'll use something like a quadratic formula, completing the square, or maybe graphing in order to solve it. Do I know two things that multiplied equals negative 12 combined equals a negative 4? Yeah. That would be a negative 6 and a positive 2. Because of the leading coefficients of 1, I don't have to worry about bottoms up. So I think one answer is 6 and one answer is negative 2. Now I do need to plug them back in to make sure the left side equals the right side. In doing so, I can see that negative 2 does not work. When you plug them back in, remember you will be plugging them into the original, not where you have a square and not, okay? So when you plug them back in to check, do they both work or just one? This is the equation that I'm plugging them into. So just 6 is the answer to number 13. Number 14, remember when you're solving a problem, when we're solving an equation, we're doing PEMDAS backwards. If we are just simplifying an expression, we're going to go down. Solving, we go back up. So on the side with the x, I'm looking to see outside of the parentheses, is there any adding or subtracting? It's right here. So opposite of subtracting 2 is adding 2. Okay? Opposite of multiplying is dividing. Okay, now up to exponents. So how do I remove a 1/3? You're going to raise it to the reciprocal, 3 over 1. And you could at this time, you could grab that sheet. This means negative 2 times negative 2 times negative 2. You can grab a calculator, you end up with negative 8. I'm going to add 2 to the opposite side. I end up with negative 6. I do have to plug it in to make sure it does work. It does work when I've gone through it, so x equals negative 6 is the correct answer.
I got these two.